Good evening, pre-calculus class. So today we're going to be jumping into section 4.2, which if you remember from last week, we were talking about the unit circle. We did like a brief unit circle thing in class. And so today in this week, this section, we're going to be talking about trigonometric functions and how they relate to the unit circle. Now this is going to start a whole unit of information on trigonometric functions and the unit circle. Now, even through the internet, I can hear some sighs, I can hear some groans. Oh my gosh, the unit circle, we're coming back to this. You guys might remember the unit circle from last year or have flashbacks from talking about the unit circle from last year. Now, the unit circle doesn't have to be boring. It doesn't have to be lame. The unit circle is really cool. Its applications show up all over the place. It describes exactly how sine and cosine functions work, which are the main functions that describe energy and waves and the way that things work. If you think about light bouncing off of any particular substance, so light bouncing off of this, right? It's going to come off blue. As it's coming off, it's a certain wavelength, and those waves travel in sines and cosines. So if you want to study things like light, if you want to study things like sound, energy, anything along those lines, you're going to end up using the unit circle. You're going to end up using sines and cosines. Really, really powerful functions that have actually quite beautiful symmetry. Now there is going to be a little bit of memorization that's going to be required in this unit. However, it's just a tiny bit of memorization. Now, you can by far definitely memorize the entire thing. I mean, it's going to take up a lot of brain space. I never actually memorized the entire unit circle. All I remember to memorize was just like a handful of things, and then I was able to derive what the rest of the unit circle looked like. Okay, so basically, we're going to start talking about the 6 trigonometric functions. Okay, and before we get into that, I want to talk about what the unit circle is. Why is it called a unit circle? Of all things. So I'm going to start off with just an XY coordinate system. XY coordinate plane, nothing fancy, nothing groundbreaking. You guys have seen this since before algebra. XY coordinates. And I'm just going to start off by plotting one point, one single point out on the x-axis. Okay, 3, 4, 5. And I'm going to plot it right there. And that point is going to be, if I want to figure it out, right? So I go 1 unit in the x direction and 0 units in the y direction. So this point is going to be 1, 0. Now if I do the same thing on the y, if I plot one single point on the y, right there, and if I go opposite in the x direction, right, one single point there, and a little bit, and same thing in the negative y direction. Okay, so if I'm just going to start labeling each and every one of these, right? So 1, 0, this one is 0 in the x direction, 1 in the y direction. It's going to be 0, 1. This one, negative 1, 0. This one, 0, negative 1. Really basic, right? So if I wanted to connect these lines, okay, so I've got my handy compass here. Do this in pencil because that's what's on my compass. So all of a sudden, I've got my compass, and I start drawing a circle, and sure enough, if with any luck, I'm pretty close to the center there, with any luck, I draw a circle, and it passes through all of these lines. Once again, all I started off with was just a simple XY coordinate plane, plotting a single point, and I said, hey, what if I plot the same sort of points all over the x-axis? Sure enough, I connect them with a circle. Now this is my unit circle. This is a circle of radius 1. And that's why it's called a unit. Anytime you hear 1, 1 is equal to unit. Okay, so the unit circle is just kind of the one circle. So it's a circle with radius 1. And with this, if we start on this x-axis and we start traveling around this circle, we can see that there's some really cool relationships that start popping up. Okay, particularly things that involve sines and cosines. Now the 6 trigonometric functions, that's what we're talking about here, trigonometric functions. Now the root of this word is tri, meaning triangle. So the trigonometric functions, and really even the unit circle, it all relates back to triangles. Okay, so if I draw a triangle and I'm looking for, you guys remember these relationships, if I'm looking for an angle here, right, and I know, say, A and B, and here I've got H for the hypotenuse, right? I know A squared plus B squared is equal to C squared, or whatever it is, right? Or I can do side angle side, or angle 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 side, or particularly like if this is a 90 degree, right, then some cool properties start popping up. Basically, I can take this circle, or I can take this triangle, and I can put it inside of my unit circle, right? And so all of a sudden, I know what the hypotenuse of my unit circle is. So if I take a line just like this, right, and then I drop it down on the x-axis just like this, all of a sudden I've got my triangle. So I know what my hypotenuse is, 1, and my angle right here, theta, if I ignore it as a triangle, if I cover this little bit up right here, holy cow, I'm just looking for the angle between my x-axis and whatever sort of angle degree or leg this little ray is at, going right here. Okay, so let's take a step back and just sort of process that for a little bit. Okay, now what I'm going to talk about is the 6 trigonometric functions. Now these ones you do need to know. You need to know what they are. Okay, but chances are you know them already. They're going to be sine, cosine, tangent, and I'll say sine of x, cosine of x, tangent of x, and then, so this is going to be the 3 of them, and then the inverses of these. Not the inverses, but the reciprocals of these. So the reciprocal of sine, so you'd say 1 over sine of x, is called the cosecant, which is abbreviated CSC of x. I do not know why. It doesn't make any sense to me why in the world the cosecant is teamed up with the sine, and the secant, so 1 over the cosine, is the secant. I could never figure out why the secant isn't teamed up with the sine and the cosecant isn't with the cosine. That would make way more logical sense to me. I've never figured that one out. But this is just the way it is. So sine is lined up with cosecant, cosine is lined up with the secant, and the tangent is lined up with the cotangent. Cotangent of x is just going to be equal to 1 over the tangent of x. So these are the 6 trigonometric functions. But the good news is you don't really need to even have all of these memorized. You just need to realize that you just need to know sine and cosine. And the relationship here, there's a relationship between sine, cosine, and tangent. Tangent is actually a derivative of the sine and cosine, meaning that the tangent of x is just equal to the sine over the cosine. Sine of x over the cosine of x. So anytime you see a tangent, you can actually just break it up into sines and cosines. Now, the definitions of these 6 functions, these 6 trigonometric functions, 6 trig functions. Right here. Now, the definitions of these 6 trig functions as they relate to the unit circle deals with sines and cosines and x's and y's. Okay? So this is another thing you're just going to have memorized. And I'm going to switch over. Sorry, instead of x's, I should have been using thetas here. I apologize. This might get a little bit confusing because I'm going to switch back over to thetas, and I'm actually going to be using x's and y's in terms of the unit circle. So if I think about the angle, right? So I'm always talking about theta. So my x-coordinate on my unit circle, once again, if I radius 1, plotting a point, I've got some angle. Sure enough, I can figure out what that exact coordinate is. So the x-coordinate is just going to be the cosine of theta. Cosine of theta is going to be equal to my x-coordinate. Got to have this one memorized. Once you have this one memorized, you can figure out, okay, well, the other relationship is pretty easy. The sine of theta is going to be my y-coordinate. Okay? So cosine is going to be 1, y is going to be other. Once again, they're obviously really interrelated here. Cosine is my x value, sine of theta is going to be my y value. Now my tangent of theta is, of course, sine over cosine, which, if I replace this, sine of theta is going to be y, and the cosine of theta is going to be x. Just like that. Now I can expand this, of course, into my cosecants, my secants, and my tangents. So really quickly, my secant of theta, because that lines up with my cosine, is going to be equal to 1 over x. My cosecant of my theta is going to be 1 over y. And then my cotangent of theta is going to be, instead of y over x, it's going to be x over y. Once again, I always start off with just this 1, and then I can say, okay, well, the cosine of theta is x. That must be the sine of theta is y. I can derive what my tangent is knowing this relationship here. And secant, cosecant, and cotangent I can figure out from there as well, because they're just the reciprocals. Now, suppose I had a point on the unit circle, and I'm looking for what the relationship is between theta and between the point. Okay, so I just want to make this really, really obvious. So the example that I'm going to give is basically I'm starting off with a point P is equal to -1/2 square root of 3 over 2. Now these numbers might look familiar. They do lie on the unit circle. Okay. If you don't know that already, then just trust me that this point is on the unit circle. So it's a point on the unit circle. It corresponds to some angle theta. So now I'm trying to figure out what the values of the trigonometric functions are at theta. Well, this isn't too tough. Okay, so I know I've got a unit circle. Without even plotting my unit circle, I'm just going to plot these points. Okay, so say 1 is out here, -1, positive, or just like this. Okay, so if I go about -1/2 and then square root of 3 over 2, that's about 0.866. So I'm going to plot my point right there. That's my point P. Sure enough, it does seem like it's going to lie on this unit circle, so I'm pretty close there. So in this case, my angle right here, it's not going to be just this angle right here, but it's going to be this angle right here. So this is going to be my theta. Okay, remember, because we're always measuring from the x-axis. So now I just need to figure out what this relationship is. Okay, so I know my x value. My x value is going to be -1/2. That's what they gave me. So I know that the cosine of theta is going to be equal to -1/2. That's easy, which is my x value. Now my y value is square root of 3 over 2. And my y value up here is the sine of theta. So I can say the sine of theta is going to be equal to square root of 3 over 2, which is equal to y. Just like that. Not too bad. I can expand it out and just say, okay, sine over cosine is going to be my tangent. All right, so the tangent of theta is going to be equal to y over x, sine over cosine. So I can say this is going to be equal to square root of 3 divided by 2 divided by -1/2. If I do some algebra mojo, I can take the bottom one, flip it up. I'm just going to multiply it by -2. Basically, this just becomes negative square root of 3. So this is the relationship that I'm looking for. The cosine of theta is -1/2. Sine of theta is equal to root 3 over 2. Tangent of theta is negative root 3. Now I can expand this over into the secant, cosecant, and cotangent, which we will be doing in class, but I don't want to waste you guys' time right now without any hands-on experience. And also the cosecant, secant, cosecant, and cotangent gets quite a bit more confusing. So I want to tackle that as a group in class. Okay, now one more example before we finish for the day. Example 2. Now in example 1, I gave you guys what the point was. Now I'm not going to give you the point, I'm going to give you what theta is. So say I want you to give me what the x, y, or the trigonometric functions are at theta is equal to pi over 2. Okay? So what point P on the circle corresponds to this? So pi over 2, because we were dealing with radians last week, pi over 2 I know, 1 full revolution is going to be 2 pi, so just a quarter of a turn is going to be pi over 2. Because I'm on the unit circle, this is really easy. So I've got my x, I've got my y. I know exactly what point that corresponds to. So this happens to correspond to 0, 1. So I go 0 in the x direction and just up 1 in the y direction. So that's going to be my pi over 2 angle. This is going to be theta. So that makes my problem a whole lot easier. So now I just need to say, okay, well, sine of pi over 2, sine of theta, which is going to be sine of pi over 2, This is going to be my y value, which is just going to be equal to 1. Right? So it's going to be my y value right there. I actually should have started off with my cosine of pi over 2, which is going to be my x value, which in this case, cosine of pi over 2, 0, or sorry, is going to be equal to 0 because my x, I'm not going in the x direction very far. I'm not going in the x direction at all, as a matter of fact. I'm just going up in the y direction. So the cosine of pi over 2 is my x value, which is going to be equal to a big fat 0. Now tan is going to be sine over cosine. Oops, sorry, the tangent of pi divided by 2. Tangent of pi divided by 2 is going to be equal to y divided by x, which is going to be 1 divided by 0. Now anything divided by 0 is totally undefined. And sure enough, if I was to plot this function, if I was to plot the tangent function, I have a vertical asymptote at pi over 2. Okay. Now I'm going to complete this one out by doing the cosecant. Cosecant of pi over 2. Remember, that's related with the sine. Right? So cosecant's 1 over the sine, which is going to be 1 over y, which is going to be 1 over 1, 1. Totally fine. Now the secant, pi over 2, is going to be 1 over x. Secant's related to the cosine, so it's going to be cosine is going to be x. So then instead of 1 over x, I get 1 over 0. So this is bad. This is going to be undefined. Now the last one is just going to be the cotangent. Cotangent of pi over 2. Now up here I've got 1 divided by 0, but because it's a cotangent, I'm going to flip it. Right? So I'm going to take the reciprocal of that. So I'm just going to end up with 0 divided by 1, which is going to be equal to 0. So 1 divided by 0 is undefined. 0 divided by 1 is equal to 0. So that's totally fine. Looking good. All right, guys. I'll stop it there. We'll pick up from there in class tomorrow. I'll see you guys then.